Hi everyone, my name is Matthew Griffin. I'm the CEO and founder of the 311 Institute, a global futures and deep futures think tank looking up to 50 years out. Now, I cross over 600 emerging technologies, I've written 15 books, I cover over 400 of the world's top megatrends. And in this particular presentation, which I actually first gave in Amsterdam to Hoogstraten, who are one of the world's largest strawberry growers, that's it, I know you all love strawberries, I talked about the future of food. And what I wanted to do is I wanted to show you what the future of food looks like, the problems that we actually have today, the challenges we're trying to solve when we actually have a look at some of the new innovations that are coming through. And I hope you enjoy the presentation. Now, when we actually think about a taste of tomorrow, and when we think about the world that we actually live in today, it doesn't matter where you live on the planet. It doesn't matter what your job is. It doesn't matter what your industry is. There is only one thing that is actually changing, and that's everything. Now, when we have a look at geopolitics, basically that's changing, obviously. When we have a look at the macroeconomic environment, basically that's changing. When we have a look at society and consumer behaviors, those are changing almost at the whim of a post on social media. Basically, when we actually think about technology, well, it's obvious that that's actually changing everything, whether we're talking about things like vertical farms, cars and fleets that drive themselves, whether we think about cryptocurrencies, artificial intelligence, gene editing, whether we think about synthetic biology and all kinds of other things. Basically, everything is changing. And when we actually think about everything that's happening in the world today, we kind of have to ask this question, what if? Now, what if, in my mind, is a really, really good question to ask, because in the context of this presentation, what if we could feed every single person on the planet quality, affordable, healthy food sustainably? Now, when you think about the impact that food actually has on your life and proper nutrition actually has on your life, today we actually see around 1.5 to 2 billion people every day going hungry or malnourished, despite the fact that we actually have an overabundance of food almost. But when we actually think about the impact of nutrition on health, whether that is physical health, it's significant. When we think about the impact of not being able to afford the food that we actually need for our families has on our mental health, that's significant as well. And that's significant in the developed world and in the emerging world as well. So what if we could feed everybody on the planet sustainably, affordably, forever? Let's dig into some facts. Now, when we have a look at today's food system, shall we call it, the global food system, realistically, it is a system that is under huge amounts of stress. And I would actually argue that as we look towards population growth, where we will see potentially 10 billion people on the planet by 2050, I'd actually argue it's a system that is actually already starting to break. And we see that, and I'm going to walk you through that. Now, what does it take to ultimately feed the planet? Let's look at some numbers. So, firstly, there are now 8.2 billion people on our planet. Many of those are in Asia, but nevertheless, how do we actually feed 8.2 billion hungry mouths every day, consistently? What we do today, basically, is we do this. We grow, or farmers grow, 10 billion, with a B, 10 billion tons of crops. Sounds like a lot, but is it? We breed 85 billion livestock. So chickens, sheep, cows, and so on and so forth. 85 billion livestock every year. When we think about the world's oceans, basically when we think about the fisheries basically that are increasingly under threat basically from global warming and warming seas, as well as rising pH temperatures, or rising pHs rather, we have to farm 124 billion fish. Now, from a farm perspective, today basically we are farming 4.7 billion hectares of the Earth's surface, or 31% of the Earth's landmass. We rely on 62 trillion tons of soil. And out of that, basically, we then add 205 million tons of fertilizer. Bearing in mind that when we saw Russia invade Ukraine, we saw natural gas prices spike by 244%, which actually meant that the cost of fertilizer tripled. So if you were a farmer basically in Africa, let alone basically in the UK or in Europe, you saw your fertilizer costs triple. And meanwhile, you ended up with food inflation because you had to pass those costs on. And that's where we saw sort of, in the early days of the war, basically we saw inflation rates of anywhere between 8% to 64%, for example, in Ghana. Now, when we think about those livestock that we have to feed, we are having to feed them 6 billion tons of animal feed. So think about this. Every year, farmers around the planet are growing 10 billion tons of crops. Not all of those are for human consumption. A lot of that is actually to feed the livestock that we then eat. Now, today, basically, when we actually think of the United Nations hunger programs, basically, we actually have 673 million people in 2024, basically, who are classified as severely malnourished. And then we have another roughly billion people on top of that, as I mentioned earlier, who are going to bed every night, should we say, not fully fed, but hungry, and so on and so forth. Now, in addition to that, depending where you are, basically, if you're in a high-income country, you are generally spending about 10% of your annual income buying food for your family or for yourself. However, when we actually have a look at low-income countries, that can actually be 40%. So despite the fact that we're producing all of this food, when we actually think about food equality from an affordability perspective, this is a huge gap. Can you imagine spending 40% of your income just on food? Not going out to restaurants, that's it, I know what you're all like, but actually just spending your money on standard basics. More stats. Now, when we actually think basically about the impact of climate change and extreme weather, whether you believe climate change or not, the fact of the matter is it's having a significant impact basically on food production around the world. Now, in 2024, we saw 80 phase 3 and phase 4 global food events. Now, the United Nations classifies a grade 3 or 4 food event as catastrophic. This is essentially the onset of famine within a region, which can be caused by a variety of different things. Now, when we actually have a look at the comparison of that, basically between 2019 to 2024, basically that was an increase basically of over 57%. That's it. So the trend's only really going one way, which is why I say that as we start projecting a lot of this stuff out to the future, we can actually see a system that is increasingly breaking. If it doesn't break, it's certainly coming under more and more pressure, which means that it's increasingly unsustainable. Now, in 2024, basically, when we actually have a look at these global food events, basically 295 million people were affected. Now, when we say affected, we're not just talking about the supermarkets running out of a bit of food or your favourite hobnob biscuits or whatever it happens to be. We're talking about people who are fundamentally basically on the starvation line. And again, basically, when we actually have a look at the number of people who were actually affected by global food events, basically between 2019 and 2024, the official figures, basically which you can see down here, or these are the sources, the official figures actually show basically that the number of people affected by these food events increased by 120%. So we shouldn't like either of these two numbers. That's it. But they don't seem to be getting any better. Now, when we think about global greenhouse gas emissions, that's it, yes, let's go there. 30% of global greenhouse gas emissions basically come from the agricultural industry. 70% come from other industries. And we've all heard about farting cows, and we've got new genetically engineered cows that don't fart as much and so on and so forth. But actually, when we have a look at the agriculture's contribution to global warming, it's actually very significant. Now, when we actually have a look at freshwater consumption as well, basically 70% of all of the world's available freshwater resources, because we have water that's locked in ice, we've got seawater, we can't drink that, etc., etc. So when we have a look at agriculture's impact and use of available global fresh water resources, 70% of that goes to agriculture. The other 22% goes to industry. So for example, glass manufacturing, steel, aluminium manufacturing, and so on and so forth. Just 8% of all of the world's freely and easily accessible water resources, freshwater resources, are used by us humans. So now consider this. We have more people coming onto the planet or being born. We need more cows, more livestock, and so on and so forth. We need more food, more crops. Basically, so this 70% number, does it decrease or does it increase over time? It increases. Now, if the 70% number actually increases, what happens to the 8%? As humans, do we actually have more access to fresh water, or do we have less access to fresh water? We have less. And last year there were 64 major conflicts over water. And again, that is another trend that's actually ticking up. Now, when we actually think about the food that we produce, 40% of the crops that we produce are decimated and killed by disease and pests. And this again is on the rise because disease likes warming temperatures, pests love higher humidity and warming temperatures. And then a further 8% of global crops were destroyed by bad weather. So for example, in the UK, if you walk around the Cotswolds, you can actually see beet farms and potato farms and farms growing cabbages and so on and so forth, and the fields are underwater. The fact of the matter is, if a field is underwater, the crops are dead. Conversely, if a field is dried out, the crops are dead. So out of that 10 billion tons of crops that we actually grow, almost 50% at a global level is being decimated by disease, pests, or weather, or all three if you're a really unlucky farmer. Now, when we think about our own planet, that's it, 75% of the Earth's surface has been degraded. We are losing 12 million hectares of farmable land every year. And over the past 100 years, we have lost 69% of species, which has caused sort of quite a lot of consternation in the expert community, because increasingly we're now talking about humans causing the 6th global extinction event. Now, when we actually think about livestock specifically, 20% of the livestock that are reared on the planet, out of that 85 billion animals, 20% of them are lost to disease. We've all seen upticks in pandemics recently, and what I mean by that is HN51 bird flu, swine flu, and so on and so forth. They're almost constantly in the news now. Now, as biodiversity increasingly collapses, as we increasingly move into areas that were previously inhabited by wild animals, we see a 3 times increase in the number of pandemics in the future. That's it. Simply because we're coming into more contact, whether it be as humans or whether it be as animals, that's it, with wild populations that realistically we shouldn't be in touch with. Now, when we think about the oceans, the ocean scene is similarly upsetting, I suppose. I'm a marine biologist by trade, so I don't like any of these numbers. Now, over the past 20 years, we've seen a 0.5 degrees Celsius increase in sea surface temperatures. Doesn't sound like much. Half a degree Celsius, you're not even bothering basically to take your sweater off, basically, if you're in the UK. However, that has led to a 30% increase in ocean pH and acidity. Now, the impact of that is 95% of animals in the ocean, like fish, like crustaceans, and so on and so forth, who actually have limestone either in their skeletons or in their exoskeletons, like, for example, sea urchins or starfish, they're all being affected by increasingly high oceanic acidity, which fundamentally means that the productivity of the fisheries that we actually rely on for those, 124 billion fish, is actually being degraded in ways that a lot of us don't actually really understand and a lot of us don't actually even think about. Now, when we think about ocean habitats, when we think about deep ocean dredging, when we think about the destruction of coral reefs and so on and so forth, as well as the general overfishing of different fisheries around the world, 66% of the fisheries that we rely on from a habitat perspective have been degraded. 66%, that's a lot. And actually, overall, when we have a look at this at a planetary scale, the fisheries yield is reduced by 3% over the past 10 years. So again, when we have a look at trying to understand whether the food production system that we actually have supporting 8.2 billion people today is sustainable in the next 5, 10, 20, 30, 40, 50 years, you can see that there's pressure through the system. And then when we think about waste, out of all of that food that we're actually producing, out of all of the food that eventually makes it to your plate, and you'll know these numbers because we see these numbers published certainly across Europe, 30% of everything that reaches your plate goes into the bin. It doesn't seem like a particularly sustainable system, really, from whichever angle you actually look at it. Now, this brings us on to kind of the next topic. If the way that we produce food today is increasingly unsustainable in the future, then should we just flip to a fully sustainable food production system? And I'll show you some of those later. Now, if we wanted to make the world's food production systems healthy, affordable, fully sustainable, if we wanted them to have a low impact on the planet and so on and so forth, at the 311 Institute, we estimate that that would cost over $350 trillion. So for everybody who's talking about clean meat saving the world, vertical farms saving the world, genetic engineering saving the world, etc., from a food production perspective, the fact of the matter is we need $350 trillion worth of capital. Now, to put that into perspective, as we move from a fossil fuel-based economy to a renewable energy-based economy, the cost of that shift is just under $95 trillion over the next sort of 30 years or so. This is a much, much bigger system to change. So ultimately, what does that really mean? Ultimately, it means that we are going to need traditional farming and we're going to need modern ways of farming. So let's have a look at some of the things that we can do. Now, when it comes to agricultural modernization, we have robots that are increasingly picking fruits. Now, these are soft fruits, these are peaches, these are apples, they're strawberries, basically they're blueberries, they're raspberries and everything else. So what we're doing is we're using some incredibly sophisticated artificial intelligence, we're combining it with machine vision and robotics, and increasingly, as we see sort of stresses on human farm labor through different immigration policies, especially as we see it in the United States, we are now able to make sure that we're only picking the right fruit at the right time, which actually helps us increase yields and actually reduce wastage. Now, when we think about strawberries, actually we're starting to use CRISPR, which is a genetic engineering technology to actually grow strawberries that are more drought resistant, that are bigger, that are more flavoursome, that last longer, basically in the transportation trucks, basically that take strawberries, for example, from Belgium to the rest of the world. So we are using genetic engineering in a variety of different ways to actually boost crop yields, but also make the crops that we grow more sustainable to flooding, drought, and so on and so forth. We're even using genetic engineering to create genetically engineered bacteria that are literally poured into the soil of farms. Now, these genetically engineered bacteria actually are great at absorbing and then releasing nitrogen. So if you think about the 205 million tons of fertilizer that we're actually using today that is derived from liquid natural gas and has to be produced in big factories and everything else, increasingly we see more and more farms actually using bacteria, that's it, to fix nitrogen into the soil. That's it. And again, basically these crops typically have a 30% higher yield. Now, when we think about traceability for supply chains, and again, this was a strawberry conference, naturally, so I'm leaning a little bit more on strawberries here. At Rice University, that's a university in America, and that's the real name. At Rice University, they recently used 3D printing to 3D print RFID electronics onto strawberries. Now, these RFID electronics were actually biodegradable and edible. But they also transmit the health of that particular strawberry or that fruit or whatever we've actually attached these to an intelligent supply chain system. So we understand the temperature in the transportation trucks. We understand how ripe these strawberries are. We understand whether they are going off, et cetera, et cetera. So we can actually use these sensors to get a huge amount of information about the individual fruits from farm to fork that we can then use to create a smarter, should we say, food production supply chain system. Now, in this particular case, these edible electronics are 3D printed onto strawberries, basically, and then those strawberries are packed up, they're put into boxes, basically they're put into the lorries, basically they're sent to the local supermarkets, they're bought, and we can trace them through their entire journey. We can even tell basically what conditions they were actually grown in, what batch numbers they are, if there's actually a problem, and so on and so forth. Now, when we start having a look at some of the other things that we're actually doing, in the United States, we've had a couple of companies that have actually used not 3D printing, but 4D printing to print these. Now, increasingly, really for about the past 7 years, we've been getting better and better at 3D printing foods. Now, these foods include everything from your favorite pizzas and chocolates all the way through to raspberries, bacon, steaks, all kinds of different things. So what happens to our food production system when we no longer need a cow? We can just 3D print a steak, as we've seen with the Left Farms in Israel. Or we can 3D print a strawberry. But then also what happens to nomenclature? Because if we 3D print something that looks a little bit like this, is this a strawberry? Is it a fruit? No. But is it edible? Yes. Furthermore, when we actually think about 3D printing, Nestle over in Japan, as well as different companies in the UK, are 3D printing individually personalized food packets for you, such as vitamins. So we can take a genetic swab from you and we can perfectly tailor the food that you eat to your individual gut biome, genome, lifestyle, whatever it happens to be. So imagine being able to get all of the nutrition that your body needs from just a single tablet. We're already there. What does that do to malnutrition across the world? Especially as the cost of doing this actually drops, as the speed of printing these different products increases, and as all of these things scale and mature. And of course, basically when we think about 4D printed foods, this is sort of what we've been printing. Science fiction fruit. However, again, when we talk about customizing all of these 3D printed foods to your specific biome or genome, etc., you can print them in these kinds of shapes. So on the bottom left that you see here, that is a new kind of sushi. In the bottom right, that's actually steak from a Left Farms. Yeah, and then when we actually think about, for example, 3D printed chocolates with companies like Mondelez, you can 3D print the chocolate in so many different ways that the texture is different. So if you think about that sort of dark texture chocolate that you like, when you eat it, it's crumbly. So with the first bite, it crumbles. But actually, as it's starting to melt in your mouth, it's fizzing. This isn't necessarily because we've changed the ingredients in these products. It's because we have 3D printed different textures into those products. So when we think about science fiction food and the ability to 3D print foods in new ways that let us experience food in new ways, the sky's the limit. Now, in addition to that, when we think about genetic engineering, we've recently seen new developments that actually mean that we can actually create small non-transgenic edits, basically within organisms. Now, what does this actually mean? Now, normally what we will do with genetic engineering is we will take genes basically from, say, one crop and implant them into another crop. So we have an individual crop, say for example wheat, that is actually made up of 2 genes or 2 distinct genes from 2 different species. Now that's a genetically modified organism, that's a GMO basically, and those are regulated in a very specific way. Now with non-transgenic edits, what we actually do is we use the gene editing technology CRISPR to accelerate that particular crop or animal's natural evolutionary cycles. So in China, we have actually seen them using non-transgenic edits to accelerate the evolution of different organisms, especially bacteria. This is sort of where it started, by 1 billion-fold. Now, what's special about this is because we're accelerating the organism's natural evolution, it's not a GMO. So it's not regulated as a GMO. From a legal standpoint, when we think about IP, when we think about plant variety rights, especially if you're a lawyer, that goes away. So these are some of the sort of rather stranger things that we're actually doing in, I say, animal husbandry, but also crop design. Other things that we're actually doing as well is we're trying to bring regenerative agriculture into the mix. We saw this with Jeremy Clarkson's farm. If you actually ever watch it on Amazon Prime, Jeremy Clarkson's farm program said what he would actually do in order to try to encourage nature back into the farm. He would actually leave channels basically within the fields that were full of wildflowers basically for bees. So the bees basically could actually come in, and then you've got natural pollination as well, because we see bee populations in massive decline. And while we actually see the Japanese specifically developing robo-bees, the fact of the matter is, as bee populations continue to decline, you can't create, I don't know, whatever the number is, something stupid, 100 billion robo-bees that will then go and pollinate basically all of your cherry blossoms, apple blossom trees, your orange trees, and so on and so forth. But also, if we use regenerative agriculture in the right way, we can actually restore the soil to its original natural state. And again, we can even restore the water cycles as well. So we end up bringing a little bit more balance to the farms. When we think about precision agriculture, yes, we're using precision agriculture to increasingly reduce the cost of farming, improve the efficiency of farming, but also to boost yields. So a very simple example here is increasingly we're seeing the use of drones to identify, for example, specific dry patches within fields or crops basically that aren't doing very well. And then from a farmer's perspective, we can either apply water to just that part of the field, or we can apply fertilizer to that part of the field, or we can go and investigate what's going on. But either way, it's a sniper-like way to farm. But in addition to that, when we think about precision agriculture, especially teamed up with autonomous vehicles, increasingly we see electricity being used to zap weeds. So this is where, for example, using drones, we can identify lots of different areas of a field basically that might actually be overridden by weeds, or we just have an autonomous vehicle that's trundling up and down the lines basically in the field. And as we identify weeds, so we're identifying those weeds using artificial intelligence, machine vision again, the system just zaps them. So you can imagine these sort of, these large, these vehicles basically just literally span, 3 or 4 lines basically on a field, and they are They're like moving platforms, and underneath the platform you just have systems that zap the weeds. That's it. Now, if you zap weeds with electricity, you kill them. But you also don't need weed killer. And when we actually have a look at the amount of pollution that is generated from weed killer, if you have a look especially at the Amazon basin, most of the weed killer runoff actually runs into the Amazon and actually destroys the local biodiversity and the wildlife. Now, when we think about autonomous farms, basically we're actually quite big on autonomous farms increasingly in the UK. This is a matter of robotics. So about 3 years ago, we used an autonomous farm actually in Devon. And this particular autonomous farm, the vehicles planted the seeds, they looked after the seeds in the field, they monitored the crops, and then they harvested the crops. That's it. So increasingly we see, should we say, Industrial Revolution 5.0 actually coming to agriculture, because originally we had the tractor that actually displaced farmhands, but actually now we have more and more technology-based automation coming into fields and farming, which means that for the first time ever, we've seen the development of the world's first, literally, fully autonomous traditional farms. And what I mean by traditional farms is these are farms with fields. That's it, as opposed to vertical farms. Now, when we think about packaging, increasingly, basically, we can actually develop we've increasingly developed new packaging. So, for example, Notpla, over in Japan, basically, this is seaweed-based packaging. So when we actually think about the foods that we eat, how we package those foods, yes, we've got biodegradable plastics. We've got biodegradable plastics that actually dissolve in seawater. We've got plastics made out of sugars. We've got sugars that make those plastics that are actually extracted that are made from extracted carbon dioxide out of the air. We've got new polymers coming through. We've got seaweed packaging and all sorts of different things. That's it. So when we actually think about the packaging that is actually involved, basically, in food production, as well as, transportation, as well as, showcasing all of these different products basically on the supermarket shelves, frankly, we have no excuse for plastic pollution any longer. Now, in addition to that, when we start having a look at some of the more futuristic areas, up in the north of England, we're actually growing protein from algae. Now, these are spirilla algae, and they are up to 70% by weight protein. So when we start thinking about where we actually get our protein from, we can get our protein from cows and chickens, obviously, but increasingly we can get our protein from not just plants, we see that, but also algae. And these are very, very protein-dense farms. They're very compact. They can be fully automated and internalized, and they are springing up all over the world. Now, depending where you live in the world, I remember going up to Paris a little while ago with Change Now. So in my early days, basically, I gave one of the keynotes at Change Now. And Change Now basically is now one of the world's largest sustainable farming and technology events held in Paris every year. Everyone was saying, and if you listen to a lot of futurists who talk about food, so food futurists, they've always said, in the future, because we see all the stresses on the global food production system, we're going to have to eat insects. That's it. And the answer basically to the, should we say, meat crisis, and the farting cow crisis was, well, if we want to eat protein sustainably, we're going to have to eat insects. Well, yes, we can farm insects, and actually they are 70% protein by weight. But frankly, not everybody really wants to actually eat insects for lunch and dinner. So what about this one? Increasingly, we are also using a NASA Mars technology to create protein from air. Now, this sounds science fiction-like, but what we do is we take carbon dioxide from the Earth's atmosphere, we take water, we use electricity, and we use a kind of bacteria called a hydrenotroph. these bacteria, when you grow them under the right conditions, are basically little packets of protein. So we are increasingly growing ingredients from air. So this is soy, this is whey, this is protein, and we've got lots and lots of different companies actually now starting to sell this basically into commercial food companies. Because if we can produce quite literally food, in this case protein from air, isn't that almost infinitely sustainable? I could take this Mars technology, I could put it into the middle of the Sahel desert in the southern Sahara, and I can grow protein or generate protein. So in addition to that, the cost of producing protein from air is now cheaper than producing whey and soy from conventional means. Then we start moving on to vertical farms. Now, the big problem that we've seen with vertical farms is while we can create fully autonomous vertical farms like those from Ox Robotics, they are very, very capital intensive. And a lot of organizations have actually had trouble getting investment from different individuals, like Jeff Bezos. So Jeff Bezos actually funded Aero Farms, basically, and a couple of others. But when we actually think about vertical farms are perhaps the most sustainable form of agriculture possible. Because on the one hand, we are growing crops indoors. So tier 1, tier 2, tier 3 crops indoors. So they're protected from all of the bad weather. Secondly, we are growing them under perfect growing conditions. So perfect temperature, perfect humidity. Thirdly, if we actually use a red kind of light, then we're growing them under the right kind of light, which actually boosts yields. Fifthly, it's a manufacturing process, so we can just continue to apply robotics, automation, AI, machine vision basically to vertical farms. Sixthly, we can grow 350% more crops in a vertical farm on an annual basis than we can in a regular field, because we can just get one crop done, get it out, grow the next crop, get it done, get it out, grow the next crop. And furthermore, basically, it's a guaranteed form of food supply. In addition to that, if we actually pump carbon dioxide into these vertical farms, then again, we see crop yields increased by another 30%. In addition to all of that, because these crops are grown in cities, they are organic. They have better taste because most of the lettuces, for example, that are grown in the world aren't grown for flavor. They're grown to survive transport from Spain or Chile, basically to their eventual markets. So vertical farms, I'm a big fan of vertical farms, but we do see investment problems actually holding the technology back, or holding basically the industry back. But this is sort of why I say to transform the entire global food production system is $350 trillion. We can't afford it, we're not going to do it, etc., etc. But this is sort of where it's a hybrid approach. And then basically when we actually think about stuff without the stuff, one of my clients is Pepsi. They are one of the biggest palm oil consumers on the planet. Now, if you go to places like Malaysia, and I've worked with the Malaysian government basically on different agricultural initiatives, the vast majority of Malaysia is actually given over to palm oil plantations. However, we can take the cell from an individual organism. Now, it could be an animal, it could be a plant, it could be a tree, it could be a coffee plant, anything. So we take a single cell from an organism, whatever the organism is, a cow, a zebra. And we can then use that to grow more of that organism. So for example, we take a cell from a cow, we can actually grow cow meat basically within a lab. This is called cellular agriculture. So we actually have steak and beef, for example, without the cow. When we think about rather silly examples, I can do exactly the same with zebras. So I can create zebra burgers in a lab. I can do the same with palm oil. I can do the same basically with trees, basically for forestry and everything else. I can do the same with pigs and bacon. I can do the same with ducks. I can do the same with chicken, and we create chicken nuggets. And when we have a look at the KFC future food programs as well as the McDonald's future food programs, that's it. Increasingly, we see a way to create food, without the original organism. We even have what we call molecular coffee. That's it. That is made without the coffee bean, but it is literally the Arabica coffee. So what happens when we can grow food in a vertical farm in Timbuktu, and then we can grow steak from a single cell from a cow? You can feed everybody on the planet sustainably, affordably, no herbicides, pesticides, no hormones involved, etc., etc. We have the solutions to feed everybody on the planet affordable, healthy, sustainable food. But it's a mixed approach. We can do the same with fish. So when we think about tuna and when we think about salmon, that's it. Again, we take a cell from a fish because we've already done it, and we grow salmon fillets, literally in a lab. And over in the United States, basically when we actually have a look at cellular agriculture, the cattle ranchers in Texas actually ended up taking the cellular meats industry to court and then to the Senate to try to get regulations imposed that would, shall we say, cripple the industry. Now, when we actually have a look at the United States from a beef stock perspective, the number of cows in the United States has fallen by over 15% over the past 10 years. And increasingly, when we actually have a look at the centralization basically of the beef market in the United States, we actually start seeing there being problems in the future when it comes to providing Americans basically with their steaks. And let's face it, I do a lot of work in America and everyone loves a good steak. That's it. But increasingly, the cost of that steak is increasing. And even though we still have 85 billion livestock, of which about 20 billion are cows, that's it, steak is at risk of becoming a much more luxury item than it already is for many people. And of course, when we talk about things like zebra steaks, for example, if we can take a single cell from any animal, a panda, a zebra, a Tyrannosaurus rex, and to make you sick, even a human, and we can use that single cell to create infinite numbers of cells basically from that original organism so that we can grow burgers or whatever it happens to be, you end up with zebra burgers, tiger burgers, panda burgers, you end up with T-Rex burgers, and as we saw with Alboros basically about 3 years ago, you even end up with human burgers. Now, to get a little bit disgusting here, what would happen if you took a cell from yourself, used it to grow a human burger, which on the one hand might be cannibalism, I'm not quite sure, that's it, and ate that? You could literally infinitely eat yourself. So with a lot of these new technologies that we actually talk about, yes, there are absolutely ethical and moral considerations to actually take into account, basically, and that's kind of separate from this. But when we really think about how science fiction we have already gotten, basically, with our food production system, we are way, way beyond the realm of sci-fi. So ultimately, when we actually have a look at today's global food production system, the question that I always see at different conferences and events that I actually take part in is, well, does the future belong to farmers, engineers, technology innovators, or does it belong to both? Now, the vast majority of events that I talk at, basically, it's either one or the other. People say, well, it still belongs to the farmers. Others basically say, well, no, when we look at transforming the global food production system, we've got to go to cellular agriculture, vertical farms, plant-based proteins, all these sorts of different things. The fact of the matter is, we need to deploy the best technologies that we can for both traditional farms and, shall we say, next generation farms and food production. And it's actually not either or, it is both. And there is space for both. But even if you actually argue that there is only space for one and not the other, then traditional farming is coming under so much pressure that frankly it's becoming unsustainable. And we can see that and we can run the numbers. But when we have a look at the cost of transforming the global food production system to, shall we say, next generation food production systems, 350 trillion isn't affordable. So it's got to be, and it will be, both. And that's it from me. So I hope that left you hungry. That's it. Now, go out, go and try some of the 3D printed foods, go and hunt down a cellular zebra burger, go and find a lettuce that was grown in a vertical farm on the Sheikh Zayed Road, basically if you're in Dubai. That's it. And actually also recognize that traditional farming is incredibly difficult. It's also incredibly expensive and incredibly hard. However, when we think about precision agriculture, when we think about the elimination of the cost of fertilizer and all these other things and regenerative farming, there is so much going on in the farming and agricultural world that it is stunning. And the only thing that I will then leave you with basically is there is no sci-fi, there is only science fact now, because we have done everything. So, take care. Goodbye.